Hey guys, so I am going to run through all the problems you have due for Wednesday. All first period students have the same problems, and all third period students have the same problems, but first and third don't necessarily have the same problems. So you're going to have to fast forward at times to get through things. Okay, so I want to start with the Google form, which all of you have the same problems for. If I see a problem like this, whoops, grab that. If I see a problem like this, I am basically saying, oh, it says H. Oh, this is saying the definition of the derivative. And what is it saying to me? It's saying, I want you to find the derivative of the function f of x equals sine x. See that function right there? And at the value pi over 6. You took a quiz where you had to do this the long way. You would go pi over 6, plug it in, pi over 6 plus h, plug it in, set up your equation. And when you set up your equation, this is what it looked like. So now you're reverse engineering. You're saying, okay, what was the original problem? Because now you know that f prime is cosine of x. So if you were to plug in pi over 6, you would get the cosine of pi over 6, which is the square root of 3 over 2. That's problem 1 on the Google form. Let's go to question 2. Again, it's saying cosine 2 pi over 3 plus h. Oh, it's saying h. When that letter h kicks off, that letter h is supposed to go, I got a derivative here. So when I have a derivative here, find the derivative of what? I'm trying to find the derivative of the function cosine x. And at what x value? At 2 pi over 3. So what is the derivative of cosine? It is negative and then the value of sine. So what is the value of sine on the unit circle for 2 pi over 3? Well, if you remember, 2 pi over 3 is over here. So the root 3 over 2, but I have to make it negative. So my answer is root 3 over negative 2, but it's negative because of the negative sign. Okay. Question number 3. I see h. H is asking me to find the derivative. The derivative of what? What's the function? E to the function, the exponential function e to the x. At what x value? Well, clearly it's this number right here. That's 4. Hey, do you remember why e to the x is kind of depressed? Because when everyone else gets a derivative, they change. E to the x stays the same, doesn't change at all. So the answer to this problem is e to the 4th power. And finally, we have this problem. It says h. What's the derivative? The derivative of what? The derivative of this function right here, which is the natural log of x. At what x value? That function right there. So what is the derivative of the natural log of x? It's 1 over x. And I'm going to plug in 7, so I get 1 over 7. And that is your Google form. So that's what we were looking for. Most of these problems are supposed to be solved very, very quickly. So if we were to give you a problem like that on a test or a quiz, that is supposed to take approximately 30 seconds to solve and no longer. Okay, we shouldn't be flipping through notes or anything like that. Just boom. H means the derivative of what? Get that derivative, plug in the x value. We have our answer. Okay, the first thing you were supposed to do was the derivatives of sine and cosine. Remember, the derivative of sine is positive cosine, but the derivative of cosine is negative sine. We have negative sine 6x. That becomes negative 6 cosine x. And using the power rule, that anytime you have x to the first power, the derivative is always just the number in front. So that's what you should get for the first problem. These are the first period problems I'm going through. Let's look at the second problem. What's the derivative of sine again? It is cosine x. What is the derivative of x squared? It is 2x. Let's go to the next one. Oh, what's the derivative of cosine, ladies and gentlemen? The derivative of anything co is negative. So negative 2 times negative sine, this is going to become a positive 2 sine x. And then using the power rule on this guy, we get 9x squared. Let's go to our next problem. Our last problem, it says we got to use the power rule, negative 10x to the first, and then minus 4. What's the derivative of cosine? It's negative sine, so we're going to make that a positive. And first period's problems are over for that first section. This is third period's problem. Again, what's the derivative of cosine? It's negative sine x. What's the derivative of anything to the first power? Just the number in front. So that's the first example. Second example, derivative of 5x squared, 10x. What's the derivative of sine? Positive cosine. There's our answer. Third problem. What's the derivative of cosine? It's negative sine. And what's the derivative using the power rule? 14x to the first. And then what's the derivative of sine? Positive cosine. What's the derivative of x squared? 2x. That's our third period problems for the sine x and the cosine x. Ladies and gentlemen, we keep plowing along. Our next set of problems was about e to the x and ln x. Remember, the derivative of e to the x is itself. The derivative of ln x is 1 over x. And there we go. So g prime x. Oh, see, you needed to know your trig function. So 6 cosine x minus x, e to the x does not change. How about that? Okay. The next set, 2 cosine x. What's the derivative of cosine? It's negative sine. I'm going to put that negative out in front. What's the derivative of ln? It's 1 over x. So we're just going to put the x in the denominator. Notice how I put this 3 in the numerator, because this is the same as saying negative 3 times 1 over x. And what's the derivative of any number? 0. So we don't have to write it. That is our derivative right there. We go to our next problem. Negative 4 sine x. What's the derivative of sine? It's positive cosine. Negative 9 ln x. What is the derivative of natural log of x? It's 1 over x. We're going to put the x in the denominator. What's the derivative of 11? It's 0. Okay. Derivative of negative 4 e to the x. We know e to the x doesn't change, so we keep it there. What's the derivative of sine? It's cosine. What's the derivative of negative 9? It's 0. How about this guy? We have, what's the derivative of x cubed? Power rule says, bring the 3 down, subtract 1 from the exponent, 3x squared. The derivative of 7, e to the x. E to the x doesn't change, so 7, e to the x. Derivative of natural log of x. What's the derivative of the natural log of x? It's 1 over x. And what's the derivative of x squared using the power rule? It's 2x. Let's go to this next one. What's the derivative using the power rule? 3x to the fourth. Multiply that 4, subtract 1 from the 4. What's the derivative of ln x? It's 1 over x. So we just put 7 and the x in the denominator. And that takes us through 8 problems, 4 of which were for first period, 4 of which were for second period. Now we get to the product rule. The product rule combines all of that. You need to know your e to the x, your ln x, your sine x, your cosine x. You also need to remember things from power rule. We can't have radicals. We can't have x's in the denominator, things like that. So all those wonderful things. Let's go to our first one. Oh, I'm still in third period. I didn't even realize that. There were 7 questions, weren't there? Dang, I forgot. So now we're in third period for the next one. I'll go back to that in a second. We have g to the x. 12x cubed minus 7 times 1 over x. So that just means put the x in the denominator. That was a repeat problem from first period. Let's look at this one. What's the derivative of sine x? It's cosine x. What's the derivative of e to the x? It's just e to the x. It doesn't change. Do you notice my constant has just been kind of coming along for the ride here? I haven't really had to do anything with the constant, because if I used power rule or product rule, that constant would disappear. So negative 4 e to the x stays the same. Negative sine x. Well, the derivative of sine x is cosine x, and the derivative of negative 9 is 0. Let's go to the next one. What's the derivative of natural log of x? It's 1 over x. What's the derivative of x squared? It's 2x. What's the derivative of sine? Positive cosine x. What's the derivative of natural log of x? 1 over x. We'll just put the x in the denominator. And what's the derivative of 11? It's 0. We don't need to write it. Oh, e to the x. What's its derivative? Doesn't change. Very depressed. It stays the same. We're done. And 3e to the x. What's the derivative of e to the x? It's just e to the x. What's the derivative of 5x squared? It's 10x. And now we're done third period. So there were 7 problems in that set. I miscounted when I put it on your problem set, your sheet. So there were 7 problems for each of them. first period and then third period. So let me repeat what I was saying before. Now we're at differentiating products, which you need to know all of your rules for. So let's read this out. The other thing we need to know is if it's multiple choice, I do have to simplify it. So we're going to practice that a little bit. Okay, so f of x is sine x times x to the negative 2. Let's say that again. Sine of x times x to the negative 2. So first, I take the derivative of sine, which is cosine. I keep the second function the same, plus keep the first function the same. I take the derivative of the second function using the power rule. So I get negative 2 x to the negative 3. Now I'm looking at this, I'm going, gosh, I think I did it right. Free response, I've done it right. I can stop. But if it's multiple choice, I need to go a little bit farther. And you can see that there's all these denominators. That's because it's taking the negative exponent and making it positive by putting it in the denominator. So let's look at what we get here. We get cosine x over x squared. So let's see who gives me a cosine x over x squared. That's the bottom two. And then who gives me a minus 2 sine x over x cubed? That would be letter C. So this is an example of a multiple choice problem, what you'll probably have in your quiz where you actually have to match it up. Let's look at this next one. The square root of x times the sine of x. Ladies and gentlemen, SpaghettiOs. We have a radical here. We're not allowed to have radicals when we take the derivative. We need to rewrite it. So there we go. What is the derivative of the first function? Leave the second function the same, plus the first function, we're going to leave the same. Take the derivative of the second function. Ladies and gentlemen, do you see a multiple choice? Do you see an instruction that says I need to get a fraction? Do you see an instruction that says simplify this and have no negative exponents or fractions? You don't see any of that. Keep it. That's a completely correct answer. You're good to go. All right. Let's look at this next one. X to the fourth times natural log of x. What's our power rule? Take the derivative of the first function. Leave the second function the same. Plus, keep the first function the same. Take the derivative of the second function. We have ourselves a multiple choice, ladies and gentlemen. None of those choices are what I have on my paper. So let's look at a little simplification. If I have x to the fourth on top and I have x on the bottom, that means I now have an x cubed on top. So let's look at our choices again. Nothing looks exactly like that, but you know what looks like that? This guy, because it's just factoring that with the greatest common factor. So it's the same problem. It just said, oh, look, both my terms share an x cubed. I'm going to pull that out. You might be saying, why in the world did it do that? Because after this section where we learn all the rules, we start using it to solve things. So we're going to use it and then factor and then solve, just like you did in Algebra 2 and pre-calc. Does this one say you have to simplify it and make it look all pretty? No, it does not. So we have to take the derivative of that function. Ladies and gentlemen, we had a problem like that in our notes yesterday. We had two different ways to do it. We could use the quotient rule or we could use the power rule. I'll show it both ways. The derivative using the quotient rule, low, d high, minus high, d low, all over, low square. That's the derivative of the first function. Leave the second function the same, plus keep the first function the same, take the derivative of the second function. Completely, perfectly fine, right answer. If I didn't want to do it that way, I can rewrite this as 1x to the negative 1 sine x, so that when I take the derivative of this, I can use the power rule. I go negative 1x to the negative 2, keep the second function the same, plus keep the first function the same, take the derivative of the second function. These both mean the same thing. Both of them mean negative sine x over x squared plus cosine x over x if I didn't have negative exponents. All three completely right answers. And if I'm you, I leave it either as this top function or this bottom function because it didn't say get it in multiple choice. It didn't say simplify. It did not say you can't have negative exponents. So just go ahead and keep it the way it looks as is. Okay, let's go to our next one. Sine of x times x to the negative 2. This is a product rule problem. Keep the first function the same, take the derivative of the first function, leave the second function the same, plus keep the first function the same, take the derivative of the second function. We have denominators. So let's get denominators here. We have cosine x with the x to the positive 2. We have a negative 2 sine x with an x to the third power in the denominator. This is exactly the same as the problem we had before. that you may have skipped ahead because we were in a different class. So I just wanted to make sure you saw that. Okay, we have our next problem. Take the derivative of e to the x, which is e to the x, leave the second function the same, plus sign. Take the leave the first function the same, take the derivative of the second function. Make sure you either put a multiplication sign or a parentheses around that, because if you don't, you're saying subtract sine x. You have to indicate that there is a multiplication, but that is the end value. We have another multiplication, so we might have to do some simplification here. I have a radical, so if I have a radical, remember, I need to make that x to the x to the 1/2 before I take the derivative. Let's do it. Take the derivative of the first function, leave the second function the same, plus keep the first function the same, take the derivative of the second function. Okay, let's look at what we have here. First of all, I don't see any negative exponents in this entire problem, so let's put that negative exponent down below. We have an ln x, we have a root x over on this side. All right, so what do we have left over? Ladies and gentlemen, let's see what we got here. I have, looking at these problems, does anything match what I have so far? No, nothing matches what I have so far. So let's figure out what needs to happen. I'm going to rewrite this real quick. 2 root x plus root x over x. So this is what I have as a derivative so far for this problem. So you might be going, oh my gosh, which one is it? Like, none of these match up. Well, first of all, I know there has to be a plus sign somewhere in here, right? So we know that A is not the correct answer, okay? Does anything look shockingly similar? Well, right now it looks like D is a winner. So let's figure this out. If I have a square root of x, or x to the 1/2 in the numerator, and I have x in the denominator, that means I have x to the first in the denominator. So whose exponent is bigger? The one in the denominator. And remember, we can always subtract them, and that's what gives us our exponent. So this becomes ln x over 2 root x plus 1 over the square root of x, because if I subtract these exponents, I get 1/2, but the bigger one stays in the denominator. That's why D is the answer. Ladies and gentlemen, the outcome of the day is, can you take the derivative? So if you could do this, we're good. We're feeling solid, but we do need to be able to match things to multiple choice answers that sometimes take some of our other abilities from pre-algebra and algebra into play. So just keep that in mind. Let's look at our last one. We have a derivative here. This is similar to the last problem, but you may have fast forwarded. So what is the derivative of this guy? Ladies and gentlemen, if I use quotient rule, low d high minus high d low, oops, that's a 1, all over low squared. Keep the second function the same, plus keep the first function the same, take the derivative of the second function. So you would have ended up with negative 1x squared sine x plus cosine x over x. Also, if you wanted to, you could have rewritten this as 1x to the negative 1, and then when you did the product rule, you would have gotten negative 1x to the negative 2, keep the second function the same, plus keep the first function the same, take the derivative of the second function, take the derivative of the second function, and we get our answers. So that is the product rule. Now we get to do our quotient rule. Low d high minus high d low all over low squared. Let's do it. Low d high minus high d low all over low squared. Does it match anything, ladies and gentlemen? Let's go look. I'm looking. Oh no, I have a positive or negative x squared, negative 2x cubed cosine x. I'm going to scratch that out, pretend I didn't say anything. Multiply these two together, I get 2x cosine x. Multiply these two together, I get positive x squared sine x all over cosine squared x. Does that look familiar to anybody? Looks good to me right there with letter B. Okay. So again, using the quotient rule, but having to simplify it. Y equals sine x, low d high minus high d low all over low squared. Do you see anything that says simplify it? I don't. I'm moving on with my life. Low, oops, that's a G, isn't it? Let's do that. Low, D high, minus high, D low, all over low squared. Let's see if we have anything that matches this. Ooh, let's see. I don't have anything that matches it. So let's see what I can do. Do you notice that all these terms have an e to the x? So cross it out here, and cross out 1 down here. Does that match anything? Voila. That's a case of factoring and matching, because when we go to our next section, we are going to have to factor to solve. Okay, next question. We have ourselves a low, D high, minus high, D low. Oh, I got to take the derivative of this. Remember, the derivative, the function looks like that. So we have 1/2 x to the next negative 1/2. All over my original denominator squared. Do you see anywhere in this paper where it says I need to simplify? I don't. I'm moving on with my life. Third period, let's see what your problems look like. Low, D high, minus high, D low, all over low squared. Ladies and gentlemen, do I see my exact answer? I do not. So we got to figure out what's happening here. I have an x squared cosine x minus 2x sine x all over x to the 4th. Remember, when there's only one term, I can just go ahead and do that. All right, I still don't see anything. So then the next thing I ask, does this term, and does this term, do they share anything? And you might notice they all have an x. So cross out this x, cross out one of these x's, and make this to the 3rd power. Do I have a match now? I do. So there is a perfect example of, we did our equation rule, but because it was multiple choice, I had to factor, find the greatest common factor, and cancel. Does this have a multiple choice? Nope. So we can leave it as messy as we want. Please notice I have a radical, and I'm going to be taking the derivative. So we might as well just write that as x to the half right now. Take the derivative. Low, D high, minus high, D low, all over low squared. Does it say simplify it? Nope. Does it say I have to make new fractions and no exponents and stuff? Nope. Leave it. Move on with your life. Next question. Cosine over sine x. Well, we're going to learn what cosine over sine x is shortly, but let's do it. Low, D high, minus high, D low, all over low squared. Does it match anything that I have up here because it's multiple choice? No, so we got to do this. We get negative sine squared x minus cosine squared x all over sine x squared. Uh-oh, it still doesn't match. So let's think. Let's factor. We always look for a greatest common factor. Let's see. Do you guys remember your identity? Cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. It's an identity. So this is the same as negative 1 times 1 over sine squared 1. And there you go. You have your answer. Okay, again, cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. Cosine squared plus sine squared is 1. It's an identity. Last problem. Let's do it. Low, D high, minus high, D low, all over low squared. We got negative x sine x. We got a minus cosine x. We got an x squared. Do I need to do any of this? It doesn't say simplify. It doesn't say get me a fraction. It doesn't say get me a numerator. Stop right there and we're done. Just make sure you have these multiplication symbols so we know when we're multiplying and when we're dividing. Maybe you want to put parentheses just to be safe. So low, D high, and D low are in parentheses, and you have your answer, and we're good to go. That was a nice little 20-something odd minute video to go through all those problems. I hope you have a lovely rest of your day. Let me turn this off while I'm talking. Bye-bye.